let's learn about service loader in Java. This is a part of new feature series in Java. Service loader is a new class which was added in Java 1.6 and it provides a very good means of developing loosely coupled applications. A application is said to be loosely coupled if it is not directly dependent upon each other. And one of the best means of implementing loosely coupled application is by using an interface. Let's see how service loader works. In the case of service loader, we have interface which is also known as service. A single interface can have multiple implementations and each of the implementation is known as service provider. Thus, there can be many service providers for a single service. Out of the many possible service providers, one is selected from it which maps the interface to the implementation, and this mapping is done with the help of configuration. The calling program will invoke call to interface, and the responsibility of loading the implementation is taken by service loader, which will load the implementation based upon the configuration done. So let's try to understand more about it with the help of an example. We have created a plain Java project with name Service Loader AG. To create a plain Java project, we have to go to File, New, and within New we can select a Java project. After selecting the Java project, we can give it a name, which in our case we have given as Service Loader AG. Along with this, we have also created a folder meta_inf within Service Loader AG. Within the source folder, we have created a package with name com.cuspon.eg, within which we have created an interface with name account. The account is an interface which has following methods: get type, get balance, get branch, and also set for each of these methods like set type, set balance, and set branch. There are two different implementations for this account interface. The first one being current account. Shown is the current account class which implements the account interface and gives body to all the methods defined within the interface. To indicate this is current account, we set the type as current account and return the type from getType method. Print out a sysout statement saying inside type of current account. In a similar way, for saving account, we make the string type as saving. Shown is the saving account which again implements account and the type of which we have made it as saving account. And again within the get type, we have print out a sysout statement which says inside type of saving account. Within meta_inf, we create services folder, and within services folder, we have created a file with name com.cuspon.eg.account, which maps to my account interface, and within this file, we will write down the corresponding implementation class which we want to use within the application. In this case, we have put com.cuspon.eg.current account. That is, we say whenever someone asks for account interface via service loader, please use current account as an implementation for this interface. That is, an object of current account will be returned via service loader. Shown is the main class. Within the main function of this class, we make use of service loader. We make the use of the static method load present within service loader, and the class which we pass is account.class, which maps to my account interface. The loader will load a variety of files. Since in our case we have only one file, we can get it by using iterator. Next, the return type is of type account, but internal. The implementation of this will be as per current account, since within the services folder we have mapped account to current account, and this will be evident via the account.getType, which will get me the type as well as print the sysout statement indicating the corresponding implementation of account. On executing the above program, within the console, we get inside type of current account indicating the implementation which was used by the service loader was of type current account, and the type is also printed as current account, thus indicating the service loader made use of current account as implementation for the account interface. Since the implementation can be varied by putting within the file present within the services folder, it creates a good decoupling between various classes present within the application, thus making a loosely coupled system. Also, it provides some amount of dependency injection, since the implementation object is created via service loader. One of the major places where service loader will provide very useful is for projects involving multiple development teams or development in an agile environment. In this case, since multiple people work on the same project, each implementing different functionalities. So let's say we have an invoking class which has to make use of an actual class, and the actual class is not fully developed. So to solve this problem, we can create a mock object which will perform mock operations of the actual class. Both this actual class and mock object will implement a interface, and the invoking class can make use of their corresponding implementations with the help of service loader. When the development of actual class is over, the mock object can be easily removed by just replacing the same from the services folder and the corresponding files mapping to the interface. Next, let's see some more Java features like concurrent package, as well as executors, as well as concurrent collections, and so on.